This meeting is being recorded.
In section 12.6, we'll take a look at another method to prepare alcohols. This time, we're going to look at something called a Grignard reagent. So that's what we see down here. We actually see how a Grignard reagent is prepared. So we have this alkyl halide listed here, this Rx. It is treated with magnesium metal. And the result is whatever this R group is, and the X group here, the alkyl halide are separated, and this magnesium kind of sandwiches or squeezes its way in between. So we can, for example, we could use this benzene ring is our R group and our alkyl halide. When magnesium is added, you can see that it kind of inserts itself between the ring and the bromine here. Something similarly with a primary alkyl halide, we see magnesium has been inserted here. So depending on whether you have an alkyl halide that's aromatic, primary, etc., we can form different Grignard reagents and then have different additions to our alcohol, different reactions occur. So we should note that the electronegativity difference is how this reagent works because of the difference in the carbon and magnesium that is inserted into that alkyl halide. We see that more of an ionic type of bond exists because of the difference in electronegativity between magnesium and then our carbon here. So the carbon's more electronegative, so it gets that kind of partial negative charge associated with it, whereas the magnesium is more electropositive. So what happens is that carbon atom will behave like it is a carbon anion. And this is both a strong nucleophile and a strong base. So that is the how this type of reaction occurs. Let's take a look at our mechanism here. So similarly with lithium aluminum hydride, our Grignard reagent will specifically the carbon in that carbon anion like situation will attack the carbonyl in this nucleophilic attack. So that carbon ion, like carbon, comes in, attacks the carbonyl, and then we form this intermediate alkoxide ion, and then again, just like the LAH mechanism and sodium borohydride, we have a final workup step where, in this case, we have our acid, our proton source, right? We see a proton transfer happen in these two curved arrows, and then our final alcohol product. But we've added that R group, right? That new CC bond. And this is the key difference in the alcohol formation process. With the other reductions and other mechanisms of action, we did not see a new CC, single carbon bond created as we do with the Grignard reagent. So this is the main difference that you should note. So we have to be careful when we want to prepare alcohols with Grignard reagents that there's no water involved, because again, the Grignard is both a strong base and a strong nucleophile. So it can act as a base if water has a, this acidic proton, it can come and grab it, and then we end up forming this compound here, like an alkane or something, right? The pK around 50. This is not our target compound either. So to ensure that we don't have water, our solvent, reacting with our Grignard reagent, commonly we can see something called an anhydrous ether used as our solvent because it does not react with the Grignard in the same way. So what we have here are some specific examples. So say we have this methyl group is our R group in our Grignard reagent, obviously prepared from methyl bromide. We have that nucleophilic attack, right, of our carbonyl, and we have now added our methyl group and reduced our carbonyl to an alcohol over here. So both of those things happen with that reagent. Same thing here. We'll add a methyl group here to our carbonyl, and the carbonyl was reduced, and now we have the alcohol. But since this, we're told this would be a chiral center. As you can see, we have 4 different functional groups, or 4 different total groups on our carbon there. We have a methyl, we have our hydrogen, we have our alcohol, and then the rest of the compound. So we would form a racemic mixture of the enantiomers of that alcohol. And last but not least, our example here, we have an ester. So we can use Grignard's reagents with ketones. That's a good thing to point out. We have a ketone here. We had an aldehyde here. And then last, we have an ester. So all 3 of these types of compounds, these carbonyl compounds, can be, we can utilize Grignard. In this case, we have excess instead of a 1-to-1 molar ratio. So we can see that we've actually added 2 of those methyl substituents now to our alcohol. And an additional product, we also produce some methanol.